welcome to All This Math. This is Professor Parker, and tonight we're going to talk about solving equations and using exponent rules. All right, now, I don't want to use this marker. I don't like that marker that much. Anyway, all right, so here we have an equation with fractions. All right, and I know that fractions are the bane of the existence of a lot of people. But here's the good news. I'm going to show you how to get rid of the fractions. So therefore, you don't got to worry about it. All right. And once you get rid of the fractions, then we just follow our typical steps, our typical rules for solving equations. The first thing you want to do is you want to basically take an inventory of each term in the equation. So I have a 1/2 x. I got 3/2 times the quantity, x plus 1. Notice how I said the word quantity. We don't say 3/2 times 3/2 parentheses x plus 1 parentheses. We don't say that. That's not sophisticated. That's not cool. We say 3/2 times the quantity x plus 1. All right. Minus 1/4 is equal to 5. All right. Now, what you want to do is you want to think of what is the least common multiple of 2, 2, and 4, and really of 1. Because this 5, oh, this marker faked me out. Oh, this marker tripped me. All right, it's cool. I got another one. Can't hold me back. Boom, there you go. So 2, 2, 4, and 1, right? What's the least common multiple of 2, 2, 4, and 1? Or what's the LCD of those fractions? The LCD is going to be 4 because LCD stands for least common denominator. So it's the smallest number that 2, 2, 4, and 1 all divide into. So what you want to do is you want to draw some brackets around the whole equation. And then you write a 4 out here. And then what you're going to do is you're going to multiply 4 by each of these terms. 1, 2, 3, 4. Not just the terms that were originally fractions where you wanted to get rid of the fractions, but every term. Okay? So what does that look like? You do 4 times 1/2 x. So 4 times 1/2 is 2. And then you have an x, so you have 2x. So this turns into 2x. Bless you, Asada.
Thank you.
You got it? Now, then we got 4 times. Now be careful with this. When you see a fraction, which is serving as a coefficient of a quantity, like a binomial, this is where it could get a little confusing, but I want you to remember. You only multiply the 4 by the fraction, right? So you do 4 times 3/2, which is going to give me 12/2, which is actually 6, right? You don't multiply 4 by x and by 1 also. We don't do that, right? We only multiply the 4 by the coefficient of the x plus 1. Because if we multiplied 4 by the coefficient and by the x and by the 1, we'd actually end up multiplying this binomial by 4 twice, right? Because by multiplying because the 3/2 was already going to get multiplied by x plus 1. So if you multiply the 4 by the 3/2, that in a way is automatically multiplying the 4 by the x plus 1. So if you already are doing that, then if you do 4 times x and 4 times 1, then x and 1 get multiplied by 4 twice. And you don't want that. Right? You don't want that. Because then what you're doing is you're changing the actual equation. It's not the original equation that you started with. So now you have 6 times the quantity x plus 1. So just be careful of that whenever you see that. When you see a fraction and you're using this method to get rid of fractions, don't multiply the 4 by everything in the binomial. Or even if it's a trinomial. Don't do that. Just multiply the 4 by the fraction in front. All right? Then we have 4 times negative 1/4, which gives us negative 1. Then the equal sign, then 4 times 5 gives us 20. All right? So now look at that. For those of you that hate fractions, for those of you that just don't bang with fractions, you don't rock with fractions, okay, cool. The fractions are gone. There are no fractions up here. Fractions are gone. All right? Now, next thing I want to do is I want to get rid of these parentheses, right? And then I'm going to combine like terms. That's the order that I'm going to work this problem out. So I got 2x, and then I got 6 times x, which is 6x, and I got 6 times 1, which is 6, and then I just have minus 1, and then I have equal to 20. So look what I got. I got 2x, 6x, 6, negative 1, and 20. Now, make sure you understand, whenever somebody's up at a board somewhere, and I mean, you're not actually in my classroom right now, but if you're in a classroom, make sure you understand the process of the problem. Don't be that student that just sits there and is totally lost and doesn't understand anything the teacher is doing, but you are intently copying down every note, every number, every plus sign, every minus sign. If you don't understand where something came from or why the teacher did a certain thing, by all means, I suggest you raise your hand and say, listen, can you tell me where the 6x came from? Because up here, it wasn't no 6x up here. Can you tell me where this 6 came from? Because is this 6 the same thing as that 6? Is that where this 6 came from? And then your teacher should tell you, no, I distributed. I multiply 6 by x to get 6x. I multiply 6 by 1 to get 6. And if you don't know where the 2x came from, because maybe you weren't paying attention for that part of the lesson, you should ask the question, where did this 2x come from? Now, 4 times 1/2 x gives you the 2x. And then you might wonder, like, well, what happened to the 3/2? Oh, 4 times 3/2 is 6. And then you might wonder, what happened to the negative 1/4? 4 times 1/4 is 1. What happened to the 5? 4 times 5 is 20. So my point is that when you're observing a person working out a problem, or you're attempting to, when you're observing a person working out a problem, you should understand every step of that problem. You should understand where everything came from and where everything is going, right? Similar to how when we watch a television show or we watch a movie, we want to understand the sequence of events, right? And the development of the plot and all that type of stuff. If there's holes in the story, then it's probably not going to be that enjoyable to us, because we're going to be confused about what's happening. Same thing with a math problem. So now we want to combine like terms. Now I underline 2x and 6x because they're like terms. That's an x to the first power, and that's an x to the first power. It's to the first power because no exponent is written, right? So it's assumed to be x to the first and x to the first. So I add those together, but I'm also going to combine these. This 6 and this negative 1. So 2x's plus 6x's altogether is 8x's. 6 minus 1 is 5. And then that's equal to 20. So I got 8x plus 5 is equal to 20. Now, I want to isolate 8x by itself, so I get rid of the 5. So I'm going to do minus 5 and minus 5. Then I'm going to have 8x, and then I'm going to have 15. And this answer is going to be a little ugly. I mean, not ugly, but it's going to be a fraction. I mean, it's not going to be an integer. It's not going to be a whole number answer. So I want to get rid of this 8. So because right now I'm trying to figure out 8 times what number equals 15. In order for me to find out that number, I need to do the opposite of multiplication, which is division. So I divide by 8 on the left, and I divide by 8 on the right. So now I got x is equal to 15/8. And if you want to be that person that deals with mixed numbers, you can do that. You can be that person. That's going to equal 1 7/8. All right. Now, we should always check our work. So I'm going to go over here, use this space right here to check my work. And going to back to the original problem, I'm going to substitute 15/8 wherever I see an x at. Here and here. So I have 1/2 times 15/8 plus 3/2 times 15/8 plus 1 minus 1/4 is equal to 5. Now, if this is a correct answer, then this will be a true statement, meaning that what I have on the left will be equal to 5. Now, let's do some simplifying. 1/2 times 15/8 is going to be 15/16, right? We understand that? Because 1 times 15 is 15, 2 times 8 is 16. All right? Now, I'm going to distribute this 3/2. I could add 15/8 plus 1 first, but because I would have to change this fraction to 8/8, I'm gonna just distribute. That's what I'm gonna do. Either way, we should still get the same result. So 3/2 times 15/8 is gonna be 45/16. 3/2 times 1 is gonna be plus 3/2, and then I got minus 1/4 is equal to 5. So now I need a LCD of 16. Now, since it's the least common denominator, I can combine all 4 of these fractions into one fraction. And then I'm going to see if that's equal to 5. Now, this already had a denominator of 16. So the numerator is going to stay the same. So that's going to be 15. This already had a denominator of 16. So that numerator is going to stay the same. Plus 45. This had a denominator of 2. You have to ask yourself the question, what would I multiply by 2 to get 16? 8. So if I multiply 2 by 8 to get 24. So that's plus 24. So this is like 24 over 16. All it is 4 different all this is 4 different fractions combined into one fraction with one denominator. But the numerators will be different though. And then 4 goes into 16 4 times. So I would have to multiply 4 by 4 to get 16. So I also have to multiply 4 by 1. So I got minus 4. Now, I simplify my numerator. 15 plus 45 is 60. 60 plus 24 is 84. 84 minus 4 is 80. So that fraction becomes 80 over 16, which is equal to 5. Is that what I'm saying? Is that true? Then the question is 80 divided by 16 equal to 5? Right? If I had to divide $80 up between 16 people, how much money would each person get? Each person would get $5. Right? Because 80 divided by 16 is 5. And because this is a true statement, then that means that this is a correct answer. There you go. All right. Now, I'm going to erase my check because I need to complete this problem in this space. But please get into the habit of checking your work when you solve equations. Actually, yeah, when you do a lot of things in mathematics, get into the habit of checking your work when you can. All right, so now we have to simplify x to the third times x to the second, the quantity x to the third times x to the second, raised to the 5th power. Now, what you want to do is you want to apply exponent rules. So you have to think to yourself, what are the exponent rules? So I see multiplication rule bit that can be used inside the parentheses, and I also see power of a power rule used because we have exponents inside the parentheses and an exponent outside the parentheses. So what I would do first is I would simplify what's inside the parentheses. When we multiply variables or numbers or any terms, we add the exponents. Multiplication goes with addition. That's one of the exponent rules that we have to commit to memory. We have to memorize that. There's no way around it. We have to memorize the exponent rules if we want to be successful in our higher level mathematics. If we want to be successful in Algebra 1, Algebra 2, Geometry, or whatever the class is, pre-calculus, calculus, and so on. So, x to the third times x to the second is going to give me x to the 5th. Not x to the 6th, because a lot of people get it confused. They see multiplication and they think, oh, I should just multiply the exponents. Nah, you don't multiply the exponents. You only multiply the exponents when there are parentheses. Think of it as kind of like the distributive property, which is like what we're about to do now. See, I have parentheses. So in this case, you multiply the inside exponent by the outside exponent. Inside exponent times the outside exponent. Again, in case you weren't listening, inside exponent times the outside exponent. So that's going to give me not x to the 10th, but 5 times 5. X to the 25th power. Boom. X to the 25th power. All right. And that should make sense because x to the 5th power means this. X times x times x times x times x. 1, 2, 3, 4, 5. That's 5 of them. And we're saying this 5 times. So if I had to write out 5x's 5 times, and you count up all the x's, how many x's would that be? It'd be 25 of them. If you had to write out 5 x's 5 times, it would be 25 of them. That's why I know also is another thing. Knowing the exponent rules is like a shortcut. It gives you an opportunity to do less work and to write out less. So memorize the exponent rules. That'll help you. All right. So we went over 2 problems today. Thank you for tuning in. I hope you learned something. Please continue to send your problems, your math problems, a picture of your math problems to the All This Math DM, and your problem might make it to this board. Peace.